All right, y'all, in this video, we're going to apply what we just talked about from video number 1. So we're going to look at 4 examples. So this first one says, prove that triangle ABC is similar to triangle DEF, and then find the length of DF. And so when I look at this triangle, I can see that angle A is congruent to angle D, that was given. And I see that angle C is congruent to angle F, and that was also given. So this is enough evidence to know that triangle ABC is similar to triangle DEF by the angle-angle similarity theorem. And so since these angles are, or these triangles are similar, we can set up a ratio of corresponding sides in order to find the length of DF. So when I look at this, I can see that side AB corresponds to side DE, and then side AC corresponds to side DF. And so if I substitute those values in, I have 3.4 over 2.72, and that would be equal to 6.9 over x. And so this is what I was talking about in that previous slide. Like, this would be a really hard problem to scale up with. And so solving it by cross multiplying might be a little bit easier for me. And so when I cross multiply, I get 3.4x is equal to, let's see, 6.9 times 2.72 is 18.768. Divide by 3.4, and we get that the length of DF is 5.52. So make sure you actually take a second and you say DF equals 5.52. All right, in example 2, it says determine if the triangles are similar and then create a similar statement and then find the value of x. And so when I look at these triangles, they're very similar to that last one, and I notice that angle A is congruent to angle H because that was given. And I can see that angle C is congruent to angle J, and that was also given by the congruent angle markings. And so that's enough evidence to say that triangle ABC is similar to triangle HGJ by the angle-angle similarity theorem. So if I want to solve for x, I want to match up my corresponding sides, and so I know that AB corresponds to HG, and then I have AC corresponds to HJ. And so if I substitute my values in, I would have x plus 1 over 3 equals x plus 5 over 6. And so if I cross multiply, this one is similar to example C on the previous page in solving proportions. And so when I cross multiply, because I want to take these numbers times the entire expression and put them in parentheses. And so when I distribute, I get this equation, and I'm going to do 2 steps at once. I'm going to subtract 3x from both sides, and then I'm going to subtract 6 from both sides. And so when I do that, I get that 3x equals 9, and so x equals 3. And that's all the problem asked me to do, was just to solve for x. So at this point, I can stop. I don't need to substitute x back in or anything. Now, I do want to make sure you guys understand that you can check your work. And so if I wanted to check, so if I substituted the 3 in over here, I would have 3 plus 1 all over 3. So I'm just substituting it back into the ratios I created right here. And so I'd want to see, when I substitute 3 in for both of those x's, if the ratios equal each other. And so this would be 4/3, and then this would be 8/6, but I can simplify 8/6 down to 4/3. And so you can see that my 2 ratios equal each other, so I know that I did solve for x correctly. All right, in this third example, it says that Min wanted to measure the height of a statue. And so she lined herself up with a statue shadow. And so I'm going to kind of draw this in. This is our statue. Okay, and this is our person. I'm going to give her a little head and arms and legs. Okay, and she wanted to, and this is her shadow right here. And then the statue shadow is this entire thing here. And so basically wanted to know how high is the statue? So this piece here. And then are these triangles similar? So let's start with this. Are these triangles similar? And so the answer to this is yes, the triangles are similar because I see I have a set of right angles right there. So there's one set of congruent angles. And then I have a triangle nested within a triangle. And so they both share this angle here that I just marked. And so when angles are shared, we know an angle is congruent to itself by the reflexive property. So yes, these two triangles would be similar to each other. But I find that taking a picture like this is helpful if I break it apart and I show the two separate triangles. So here is, let me redo this. Here is triangle 1. This is the statue and the statue's shadow here. And then this is Min. Let me redo that. There's my shadow. This is the statue. And then here is Min. And so here's her shadow. And so, okay, so if I label these, I know that the statue shadow is 84 feet. And we know that Min's shadow is 12 feet. I didn't do a great job making that. Let me actually change this because this triangle is not super kind of proportional when you look at, not really drawn to scale, I should say, and so that I don't want it to confuse you. Okay, so let's make this a little smaller. All right, there we go. That's a little bit better. So her shadow is 12 feet long. The statue shadow is 84 feet long. And then she is exactly 5 feet high. So then the question is, what's the height of that statue? And so we know that these two triangles are similar because they both have a right angle. And this was the angle they shared. So if I set up a proportion, I would do the statue's height to Min's height. Okay, and that is going to be equal to the length of the shadows. So I'm going to start with the statue's shadow to Min's shadow. And so there's my proportion. And so I'm going to make a little note here. These are the shadows and these were the heights. So I matched up corresponding pieces. So if I wanted to solve, I would do cross multiply. So I'd get 12x equals, and then 5 times 84 is 420. Divide both sides by 12, and we get x is 35. And so x represents the height of the statue. So we would say the statue is 35 feet tall. So always make sure you take and you actually answer the question. All right, so this last example says, suppose a person is 5 feet 10 inches tall and they cast a shadow that is 3 feet 6 inches tall. So here is my person, and they're casting a shadow. And it says at the same time, a flagpole casts a shadow. So let me draw a flagpole. And I always tell students, don't laugh at my picture. I do the best that I can. I'm definitely not an art teacher. I don't think that was too bad. And so the flagpole casts a shadow that's 12 feet long. And so notice 12 feet long, that's a pretty easy measurement. But when we talked about the fact that this person is 5 feet 10 inches tall, let's think about that for a second. If something is 5 feet 10 inches tall, and this example or this measurement here is 12 feet, I need to make sure I understand that when I say 5 feet 10 inches tall, that's not how I write that. Because I have to remember that inches, there are 12 inches in a foot. And so when someone is 5 feet 10 inches tall, that's really the fraction that would represent that. So if I take this fraction and convert that to a decimal, I would get 5.83 repeating. So that is the appropriate decimal. And then same thing if I say that person is 3 feet 6 inches tall. I'm not going to write that as a decimal as 3.6 because, like I said, our inches aren't there's not 10 inches in a foot, there's 12 inches in a foot. So I have to understand that when I convert 3 feet 6 inches, I have to think of that as 3 feet, and I have 6 out of 12 inches. Well, 6 out of 12 is really 3.5. So these are going to be the measurements I use over here in my drawing. And so this person's shadow was 3.5 feet. So I can put 3.5 feet there. And then their height was 5.83 repeating. And that was tall. So that was her height. And it says, how tall is the flagpole? So this is what I'm solving for. So when I set up a proportion, I'm going to match up my corresponding sides. So I'm going to match up the heights of both the flagpole and the person. So that would be x over 5.83 repeating. Now, when I put this in my calculator, I'm going to actually do several threes so I can make my answer as accurate as possible. And so this particular ratio represents the heights. And so then I'm going to create a ratio on the other side that represents the shadows. And so I need to go in the same order. I went from the flagpole to the person. So I need to go from the flagpole shadow, which is 12, to the person's shadow, which is 3.5. And so when I set this up and cross multiply, I would have 3.5x equals 12 times 5.8, and like I said, I'm going to do a bunch of threes in my calculator so I can make my answer as precise as possible. And when I do that, I get 69.9999999 repeating. And so that's enough to say that it would be okay for me just to round that up to 70. And so then if I divide both sides by 3.5, I get that x is 20. And so what does this mean? It means that the flagpole is 20 feet tall. Remember, always take a second. Don't just say x equals 20, like, what does that 20 mean? Give it to me within the context of the problem.